Hello students, welcome to Jceece connected selection number 23 network theory class 18C32. So we'll continue with the numericals on source transformation. So quickly move on to the problem statement. So using source transformation, find V. So in the given circuit, so I need to find V for the using what source transformation. Where is that V? So here is the V, voltage across 20 ohm resistor. So I need to find voltage across 20 ohm resistor using what? Source transformation. So as I explained in the previous numericals, whenever the parameter is asked across any like resistor or voltage source, anything, so that part we should not touch till the end of the solution using source transformation, right? So in this numerical we should not touch this part till at the end. So we can alter these parts, left hand part and right hand part of the circuit using source transformation, right? So in the first step I will convert the given circuit into what? See, this current source is in parallel with the what? 15 ohm resistor. So this can be converted into a voltage source with a series of 15 ohm, right? So here is the upper side direction, so this will be plus and minus, right? So this will become a parallel resistance 15 ohm here, but once you write 15 ohm here, this 15 ohm and 5 ohm are in what? In series. So that results in what? 20 ohm. So remaining part will be as it is. This is 20 ohm minus this is V, and here a one voltage source minus and plus the value 20. See here one current source again in parallel with the 5 ohm. This can be rewritten like this. 5 ohm parallel can be written in series, but a voltage source will be in series. So plus and minus because upper side is the what? Direction. Now our task is to what? Find what is this V here as well as V here. So we know that V equal to what? I into R from Ohm's law. So what is I here? 2. What is R here? 15. So V equal to I into R will be what? 30. So this will become what? 30 volts. Similarly here V equal to I into R. I is what? 1. R is what? 5. So therefore it is a what? 5 volts, right? So this is how. So this can be redrawn the previous circuit, right? So again the simplification can be done. See here, this 20 volts and 5 volts are connected in series, right? So how this can be reduced? Subtract from each and other 20 minus 5, but write the sign of a bigger values or magnitude voltage value. So I'll rewrite the circuit diagram again here. You see, so 30 volts as it is. So this is what? 20 ohm, and this part will be as it is 20. So plus minus this is V, this part as it is. This can be written as, say, 20 minus 5 will be what? 15. So but sign of that will be written according to the bigger value. So this is what? The 15 volts, this 5 ohm as it is, this 5 ohm as it is, right? So further we can modify, but we should not touch this part. Why? Because the value or parameter we are finding out across this register, right? So therefore further we can rewrite the circuit. See here, voltage source is in series with the 20 ohm resistor. This can be rewritten as a current source with a parallel resistance. So this resistance remains same, it's 20, but I is what? V by R. So that is 30 by 20. How much you'll get? It's a 1.5 ampere. So next part will be same as it is, right? So 20 plus minus, this is what? V, right? Next, see here, again there is a voltage source is in series with the 5 ohm resistor. So this 5 ohm resistor will become what? Parallel 5 ohm, right? Here is a one voltage source. This can be rewritten as a current source. See here, plus sign is in this way. So therefore the current source with a downward direction. So what is the value of current source? I equal to what? V by R. V is how much? 15. R is how much? 5. So 15 by 5 will be what? 3. Now see here, this 1.5 current source as well as 3 amperes current source are connected in parallel. Similarly, this 20 ohm and 5 ohm are connected in parallel resistance. Its equivalent will be what? 20 into 5 divided by 25. So this results in how much? 4. Right. So these two are connected in parallel, but see the direction. So maximum value is here 3, so which is in downward direction. Therefore 3 minus 1.5 will be what? 1.5, so which is in downward direction. So I'll rewrite that actually. So this results in 1.5 current source, 1.5 current source with a downward direction. Then the equivalent resistance will be what? 4 ohm, and then this will be what? 20 ohm as it is, plus and minus here V. So the magnitude of current source here is what? 1.5 amperes in the downward direction. So we need to find V here. So furthermore we can convert this voltage source with a series resistance. So this can be written as, see, it is downward direction, so plus and minus in this way, right? So this resistance 4 ohm will be in series, and then 20 ohm will be in series again. This will be V I need to find. So this is what 4. So what is this V? V equal to what? I into R. What is I here? 1.5. R is how much? 4. So what is the result of this? So this will be what? 6. So now if I apply a KVL here, say X, a loop current X. So start from this point. So what is the equation? Plus 6 plus entry sign plus here minus entry sign here plus minus. So here it is a 4x plus what is that? 20x, which is equal to 0. So 24x, which is equal to minus 6. X will be what? Minus 1 by 4 amperes. So which is the what? Current flowing through what? A 20 ohm resistor or this 4 ohm resistor. But what actually I required? So V, voltage across 20 ohm, will be what? A current X into 20. What is X value here? Minus 1 by 4. So it should be 20. So how much I'll get? It's a minus 5 volts. Voltage across 20 ohm will be what? Minus 5 volts. This is what the required solution for the given numerical. Understood? See, as I mentioned, so they have asked the voltage across what? 20 ohm resistor, right? So till end, so this part we are not touched, means we are not disturbed, we are not altered. So in the source transformation, this is what very important. Okay, so let's move on to the next numerical, right? So problem statement goes in this way. Use source transformation, find the power delivered by the 50 volts source in a given network. So it's need to find power delivered by what? 50 volt source using what? Source transformation, right? So it meaning of that will be this part of the circuit you should not alter till the end of the solution, right? So that is sure, right? So again rewrite the circuit. So this circuit can be rewritten in this way. So this 5 ohm and then this 50 volt source will be as it is, right? So this current source of 10 amperes can be written in this way. Then this 2 ohm can be written so in this way. Then there is a 3 ohm resistor in series with a voltage source. This can be written in parallel with a current source, right? What is I value here? So this is 10 amperes, this is 2 ohm, and then I will be what? V by R, V by R. Okay, so 10 by 3, so this will be what? 3.33 amperes, right? So further, what are the simplification we can do here? So you can observe here, this 10 amperes current source and 3.3 ampere current source are in parallel. So what is the result out of this? It's the addition of these two. And then what about these two resistor? 2 ohm and 3 ohm are connected in parallel. Resultant will be what? Product divided by sum. It's a 6 by 5. That results in what? 1.2. This results in what? Current source. It's a 13.33 in the upward direction. I'll rewrite the circuit again. This is 5 ohm, then this is 50, this is 50 volts. This will be what? A resistor. This will be resistor 1.2 equivalent, that is 6 by 5. It's a 1.2. One more is what? A current source with the addition of these two in upward direction, that is 13.33 amperes, right? Further, what they have asked, power delivered by 50 volts. Though this part we should not touch, right? I'll redraw the circuit again here. So that's what here it's a 5 and minus plus, it's a 50. See, this can be converted a voltage source with a series resistance. Series resistance will be what? 1.2. So I need to write here plus minus 5 because arrow mark in upward direction. So we know that V equal to I into R. I is how much? 13.33. R is what? 1.2, right? So this results in almost what? 16, right? Now further we need to apply KVL here. So you can take X or I, whatever. So write the KVL equation here. Start from this point. Minus 50, entry sign plus, exit sign minus, plus minus. Write the equation. It's a 5x plus 5x plus 1.2x plus 16 is equal to 0. So this results in what? 6.2x, which is equal to, this is 50 minus 16, so 6.2x, which is equal to what? 34. X will be how much? 5.48 amperes. Is this a solution? No. So we have found out the loop current, right? So but what they have asked, find the power delivered by the 50 volt source in a given circuit. So I need to find the power delivered. So we know the current flowing through this voltage source. We know that P equal to what? V into I, right? Right. So what is the V value here? Voltage source 50. What is I value? Means what is the current flowing through here in this loop? It's a X, right? So it is a 50 into 5.48. So results in what? P is equal to 274 watts. So this is what the required answer for the given circuit. So this is how the solution goes, in this way. So problems are very simple, but the thing is that whichever the parameter they will ask across any parameter, so that part we should not touch till the end. You can observe here. So this part remains same till the end of the solution. The end answer is what? 274 watts. Okay, so stop it here. Rest all the things will cover in the next class. Thank you.